what are structural isomers? So, structural isomers, let's see what we have here in terms of information. Oh, structural isomers are just things that have the same molecular formula, but just different structure. So it's kind of in its name. So structural isomers. Okay, so like I said, same molecular formula, different structure. Now this is just one type of isomers. There's also things called constitutional isomers, which are even like similar structure, but they're kind of like twisted in different ways. But we're focused on structural isomers today. And the way that works actually is that, so let's see here. Let's say if I give you C4H10. This right here is also known as butane. But I could draw it like this. Okay. Or I could draw it like this. Yep. Those are really the only two I could draw it as. And you notice actually that if you count the hydrogens, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So both of these are still C4H10, but this one here is called isobutane. That's just the name if I remember correctly. Yep, that is it. Very pops up a lot in chemistry, which is why I just remembered off the top of my head. But exactly, these are what structural isomers look like. And it's important that you note this because you maybe ask questions like this where it's like, which of these are structural isomers? So with that, that is in a sense what they are. Just make sure that you're counting your properties correctly. You don't want to miss a hydrogen or a carbon or any other element that might show up and assume that it's not a structural isomer. And make sure they match exactly the same. Like for every carbon one has, that one has to have the same amount of carbon, and that applies to every other element there as well. So let's see what they have. So chain isomers, which is kind of like what we did here. You see they actually use the butane and isobutane. They have functional group isomers, where interesting enough, they have first an alcohol, and then actually that's not alcohol, sorry, this is an ether, I believe that's what it's called. Let's review that. And then they have propanone. That is not an ether, that is oh wait, no, not even an ether. Both of them are ethers. They're acetones and ketones, and acetones I believe, because ketones are the ones where the oxygen's in the middle, and then the other one is where the oxygen's at the end. But point being is this is another example of a structural isomer. See how they look different, but if you count it, they have the same exact amount of elements for each type. And the last one to talk about, position isomers, is just when you move like any halogen or type of structure around the chain. The point being is that they still have the same exact amount of everything else. So that is what structural isomers are. Just to recap, same molecular formula but different structure. If it's easiest, think of the butane example where you just move the bond. In fact, I could even show that. You move this bond and you put it down here, and bam, that's butane versus isobutane. So with that, question 6.